Hello, so in this lesson, we will explore similar triangles and how to solve for missing sides. I'm going to show you two different ways. So choose the one that you're more comfortable with and go for it. So here, how do we know the triangles are similar? We know triangles are similar when their angles, all their three angles are the same. So here, if we notice angle A has the check mark and D has the check mark, that means these two angles are supposed to be the same. And this angle B and E have a similar circle here, indicating that this angle and this angle are the same. That's why we put similar shapes. Now, we all know the sum of angles in a triangle is 180. So one rule you should know that if we have two angles in both triangles that match and they are the same, then the third angle, which is here, also must be the same. That's the conclusion. So if these two angles are the same in a triangle, then the third angles must be the same. All right. Once you do that, then you could solve for any sides that are missing. But let's do something else first, okay? So we write proportions, and the proportions that we write is side AB, which is from the check mark to the circle, over DE, which is the same as from D check mark to the circle, or the little circle there, should equal AC over DF, should equal BC. You notice the top is always the triangle on the left side here, and on the bottom, the triangle on the bottom, on the right side right here, over EF. Why BC over EF? Because BC is from the little circle to the X, and also EF is from the little circle to F. Okay, that's one way you could solve this. And the second way, you also could go AB over BC is proportional to DE over EF. That's another way that you could use. So AB over BC. So AB over BC is the same as DE over EF. And you could use this kind of proportion with any side you wish. You could go AC over BC is the same as DF over EF. Okay, so that's another way that you could use. I like using this myself, so I'm going to stick to this in this lesson. So therefore, you have to figure out what you're looking for. So you're looking for X, which is AB, and therefore you go, okay, X over DE, which is here, that's 15, equals, now definitely you want to go, you don't want to go AC over DF, because if you do that, let's say we do that, okay, we go 38 over Y, because AC over DE is 38 over Y. Now we cannot solve because we have two unknowns in the equation. So I don't want to go with this option. So I'm going to skip this and go to the next one. And the next one is BC, which is 40, over EF, which is 27. Now we have only one unknown to solve for. And you know, I was showing you in the last few sessions that just cross multiply the 15 into 40. So cross multiply. So therefore, X equals 15 times 40 over 27. And let's see if we could do that without a calculator. So 15, 3 goes into 15 5 times, goes into 27 9 times. I cannot reduce anymore. So the answer is 200 over 9. And we just leave it in fraction form. You could always find out what it is in decimal as well. Okay. Now we have another missing side, which is df, which is the y here. So what I'm going to do, you see this relationship right here? If you could flip all of this, you could rotate all of this if you want, or you could just work from here. Okay. So let's maybe just work from there. And then I'll take you back to the last, not the last one, but the one before the video that I uploaded about cross multiplying. Okay, so now we want to solve for df. And so we have AC over df, AC, which is, so now solving for y, just to say here, we're solving for y. So we have AC, which is 38, over df, which is y. That's what we're looking for, equals, we're going to use the BC over EF because we already know what that is. That's 40 over 27. So BC is 40 over 27. So as I said in previous lesson, when you have this kind of situation and y is on the bottom, you could rotate all of this. And then this becomes y over 38 equals 27 over 40. Now cross multiply the 38 right there. And we have y equals 27 times 38 over 40. 2 goes into 38 19 times and goes into 40 20 times. I think I'm just going to use the calculator on this because it's not as simple as the other one. And maybe we'll just give a decimal answer for that one. So 27 times 19 divided by 20 equals 25.65. So basically that's how we find sides that are or sides that are missing in similar triangles. We write our proportion right here, and then we could use this to solve for anything in here. Okay, so let's move on to the next question. And the next question is, they haven't given me any angles here, but the properties of parallel lines tells me that this, because this line is parallel to this line, then this angle here is vertically opposite to this angle. So these two angles are the same. Yeah. And also this angle here is vertically opposite to this angle. And therefore the third angles must be equal, this and this. Or also we know that these two angles are vertically opposite, so they should be the same. So I'm just going to put an X here. And based on that, I'm going to write what the proportion is. Some students, they like to break these two triangles down and put each triangle separately and then look at it that way. So, but honestly, I'm not going to do that with this one because it's very obvious. All right. So the proportionality that you want to write is, and you know what, even if you don't want to go G, J, and H, J, and all of that, I could write the proportion here right away. So I could go, I could work from here to there, or I could work from here to there. So because my unknowns are in this triangle right here, which is this one right here, I'm going to work from here to here. So what I'm going to do, I'm going to say y over, y is from the shaded dot to the circle, and therefore y is proportional to this side here, the GH, which is the 22. So I'm going to go y over 22 equals, I'm going to go the 18, which is this side right here. And this side is from this little circle to X. And I'm going to find out, sorry, the side is supposed to be 30 in the question. So 18 is from the little circle to X, but on this triangle from the little circle to X is 30, so it's going to be 18 over 30. And we could see right away now, we could solve for y by just cross multiplying that into here. So we have y equals 18 times 22 over 30. Now I'm gonna reduce 6 goes into 30 5 times, goes into 18 3 times, so that is 66 over 5, and I'm just gonna leave it like this. You're more than welcome to go and find out what the decimal answer is using your calculator. Now let's go find the other unknown. So I'm gonna start with the unknown. I'm gonna go for x, I'm gonna go x over, so x is from the x or the little x here to the dot, and from the little x to the dot here is the 35 on the other triangle, so I'm going to put 35 into here, and then I'm going to use the same thing, 18 over 30. And you know how I went x over 35? I must go 18 over 30. I cannot go x over 35 and then I go 30 over 18, because I started right here with this little triangle. So x over 35 should equal 18, which is from the little circle to the x, and from the little circle to the x here is 30, but I could just steal it right from here. And now I'm just gonna cross multiply right here, and therefore x equals 18 times 35 over 30. 5 goes into 35 7 times, 5 goes into 36 times, 6 goes into itself once, it goes into 18 3 times. We don't need a calculator. The answer here is 21. So x equals 21. Okay, so now let's go to the last question, which is going to be a little bit harder. And it is right here, okay? So here we have two triangles, and is the big one right here and the small one right here, okay? What you notice here, this triangle right here and this big triangle right here, when you draw them out, they're gonna share this angle. Both of them share this angle. So if both share this angle, then in this small triangle here, this angle here and this angle must be the same. So let me say that one more time. This big triangle right here has this angle, and the small triangle right here has this angle. So this angle is shared between the big triangle and the small triangle right here. And therefore, since this is shared, and this angle in the small triangle equals that angle in the big triangle, then their third angle must be equal. And you know what? I'm just gonna go and draw both triangles here to make sure that you'll be able to see this, because this one is a little bit harder to see unless you break down the two triangles. So here I just took this triangle out and put it right here, and then I draw the big triangle right here. Now the length of this side here is 32 plus 32, because that's the whole thing, 64. This is 25, and all of this will be the y plus 36, which we wrote right here. And here we have the x, we have the 32, we have the 36. This is our shared angle, which is right there. This angle, we said it equals that angle, and therefore, or this angle was equaling that angle, and therefore the third angle here must equal that third angle. So as I said myself, I don't like writing A, B over that, B, C, D. I don't like doing that myself. You're more than welcome to do it. So let's aim and solve for the first thing. And what I'm gonna write here, we're gonna solve for x first. Okay, so the x, okay. So I'm gonna go x, okay, over. Now when you go x from here, you have to find the corresponding side to x. So x is from the check angle to the little circle angle. So from the check to the little circle is going to be over 25. So let's say I go from the shared angle to the little circle, which is 32. Then I have to do the same thing here. I will go from the shared angle to the 36 right here. Then this side here will be y plus 36. So you'll see that we'll have two unknowns, and then it's a problem. So you don't want to definitely use this side and this side. So we're going to go from the check to the shared angle, which is the 36. And since x was first on top here, so the 36 is going to be on top right here, over, and from the little check to the shared angle is here, the little check, and the shared angle is 64. So that's over 64. Now cross multiply like that. X equals 25. That's 25, not 26. Times 36 over 64. I'm not even going to bother with this. I'm just going to do it on the calculator. And it's going to be 14.1. Now we finished, we found the X. Now we want to find the Y. So I don't advise you to go from here to here. Now I advise you to go from here to there. So you start off with your unknown, which is Y plus 36. So you go Y plus 36 over Y plus 36 from the circle to the shared angle. So from the circle to the shared angle on this triangle here is the 32. So that's what I put in here. Equals. Now I'm just going to go with the stuff that we know already, 36 over 64. But you don't want to write 36 over 64 because 36 over 64 was going from here to here. But here we started from this triangle right here. So we went Y plus 36 over 32. Therefore, we have to go 64 over 36. 64 over 36. Now I'm going to cross multiply that into here. And I get Y plus 36 equals, and I'm just going to do that in the calculator. So 32 times 64 divided by 36 equals, and that gave me 56.9. And therefore, Y equals 56.9 minus 56. 56.9 minus 36, which is 20.9. So Y is 20.9, but the length of AE, so if you want to find the length of AE, we put a little line right there to say that line AE is basically 36 plus 20.9, which is going to be 56.9. And that's basically how you do similar triangles and solving for the missing sides. At the beginning, I showed you how you relate one triangle to another. And after that, I just showed you the shortcut that you could do without having to write the proportions, you know. So hopefully this helps you with your similar triangles. That's Math 10 again. Revisiting Math 10. I haven't finished the curriculum for Math 10, and I still have this and trigonometry, and this is part of trigonometry. So trig is going to be next, and dealing with sine, cos, and cosine. Till next time, bye-bye.